Everything around us is made of matter, from the air we breathe to the food we eat. Matter comes in different forms, and each form has its own special properties. These properties help us figure out what something is made of and how we can use it. Some properties of matter include its size, shape, and how it feels. We can also measure matter by checking things like its weight or how much space it takes up. These properties help us identify and classify different types of matter, and they also help us understand how matter can change when it's combined with something else. Today, we're going to learn what happens when we mix different substances together to make a solution, and how matter behaves when this happens. When we combine different things, we create mixtures. A mixture is when two or more things are mixed together, but they don't change what they are. For example, if we mix sand and water, the sand stays sand, and the water stays water. You can still separate them easily by pouring the water out or using a filter. But when we make a solution, something a little different happens. In a solution, one substance dissolves in another, and it looks like they have become one thing. An example of a solution is when we mix sugar into water. The sugar disappears, but it's still there. It just dissolves into tiny pieces that are too small to see. This shows us how matter can change its form, but it doesn't disappear. One important thing to understand about solutions is that matter is always conserved. This means that no matter what we do, the total amount of matter stays the same. Even though the sugar seems to disappear when it dissolves, it's still there. If we were to taste the water, we'd know the sugar is there because the water now tastes sweet. This is an example of cause and effect. The sugar dissolves into the water, and now the water is sweet. Even though we can't see the sugar, its properties are still part of the solution. We can also compare the properties of the substances before and after they form a solution. For example, before you mix sugar into water, the sugar is a solid, and the water is a liquid. Once the sugar dissolves, it seems like it has changed, but the water is still liquid, and the sugar hasn't disappeared. If you wanted to get the sugar back, you could let the water evaporate, leaving the sugar behind. This shows us that the matter hasn't gone anywhere. It's just mixed together in a way that makes it hard to see. Another example of a solution is when we mix salt and water. Just like sugar, salt dissolves in water, making it look like the salt has disappeared. But we know the salt is still there because the water tastes salty. If we wanted to get the salt back, we could heat the water until it evaporates, leaving the salt behind. Before mixing, the salt and sugar are both solids, but after they dissolve, they seem to become part of the liquid. This helps us understand patterns in how substances interact with each other. For example, we know that sugar and salt will always dissolve in water, but things like sand won't. These patterns help us predict what will happen when we mix different substances together. In solutions, the properties of the substances are still there, even if we can't see them. The sugar is still sweet, and the salt is still salty, but they've mixed so well with the water that we can't see them anymore. The key idea is that matter doesn't disappear. Even when it changes its form, it's still there. This concept of conservation of matter is important in science because it helps us understand that the things we mix together don't vanish. They just change how they look or behave. In summary, when we make a solution by mixing substances like sugar and water or salt and water, the matter is still there, even if we can't see it. The properties of the substances before and after mixing tell us that no matter is lost. It's just mixed in a way that makes it harder to see. Solutions help us understand how matter interacts and how it's always conserved, whether it's dissolved or in its original form.